I've been watching a lot of tutorials on inversion of control lately, and one of the things that those tutorials have taught me is that most people talking about inversion of control don't understand inversion of control. And that's why I put this tutorial together. I want to really just explain to you what inversion of control is in simple, clear, and unambiguous terms. But before I do, you need to promise me something. You need to promise me that you're going to forget everything that you think you know about inversion of control. Forget about coding to an interface. Forget about polymorphism. Forget about dependency inversion. Forget about impl classes. If those things mean nothing to you, well, consider yourself lucky. If they do, well, let me just say that if somebody tries to explain inversion of control to you and they can't explain it without talking about those things, then they fundamentally don't understand what inversion of control is about. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com, and I have to be one of the world's biggest advocate for inversion of control frameworks like AngularJS, Python's Flask, and of course, Spring Boot as well. And I always find whenever I'm doing tutorials on those things, people keep asking the same question, which is, what is inversion of control all about? And for that matter, when I hear people talk about it, I realize that they just fundamentally don't understand it. And what I want to do is I want you to just give me a few minutes of your time, and I guarantee you that when I'm done, you're going to be very, very dangerous when it comes to this design principle. What I'm going to do is I'm going to first just describe what it is, just give you the definition, at least give you my definition, which I think will make it very easy to understand. And then I want to go through a few examples that really drive home exactly what inversion of control is all about. But giving you a quick definition of what the inversion of control principle means, that is what we're going to do next. The inversion of control principle is deceptively, I might even say disappointingly simple. All it says is this. It says developers should keep their business logic clean and lean by taking complicated and complex tasks and pushing them out to an external framework. Those complicated and complex tasks include things like managing the lifecycle of components that have complicated life cycles. It means pushing out the configuration of components that are highly parameterizable. It means pushing out any interactions with low-level systems. Push all of that out to a framework where someone who's smarter than you, better looking than you, more successful than you knows how to do it properly. And you just focus on your business logic because that's what you know best. Now, there's another part of inversion of control that is required, but it's more of a result of doing the first part properly. And that is, if you allow an external framework or you allow an inversion of control container to manage the life cycle of your components, to handle all of the low-level systems interactions, well, what ends up happening is when your application runs, you don't actually call the framework, but instead, the framework calls your code. We call it the Hollywood principle. Don't call us, we'll call you. And that's an important part of an IOC container. If you're actually just calling APIs, well, you're not using a framework. You're just using a library. If the framework calls your code when things arise, when events happen, when it's needed, well, then you're doing inversion of control. Let me give you a nice little example that really drives exactly what inversion of control is. Let's take a look at this code right here. I've got a little RESTful API here. I don't even know if you can call it a RESTful API, but you can see that if we go to, localhost 5000/hello, it prints out hello world to me. Now, I implemented this by using this code over here. Now, do not feel the need to understand any of this code. I actually just got it from ChatGPT, so I don't understand it either. But basically what this code does is it allows me to create a RESTful API that handles GET requests, and it does it by using all of the core Java APIs. There's a socket in there, there's an IO exception. I actually got a call from my bank. They said, I owe them this, I owe them that, so they're throwing exceptions at me too. It's got a handle request. It's a mess. Okay, I don't feel the need to understand any of that code, but I do know that got /hello on port 5000 to print out hello world to me. So, okay, that code works. However, all I wanted to do was print out hello world, and that's a whole lot of code. The inversion of control principle would say, you know what? Get all of that code out of your business logic. Okay, let some external framework handle all of those low-level interactions, and don't sit around listening on port 5000 for a request to come in. Instead, let the inversion of control framework wait for the request to come in, and when the request comes in, it can call your code. Over on the right-hand side here, I've got a REST API developed using Spring Boot, the Spring Boot inversion of control framework. This code is almost identical to what you would see with Python's Fast API or Python's Flask. So the concepts are really universal. But what you can see here is I've just written some code using Spring Boot. I've said, you know, I want to deal with some REST. I want to handle the /hello interaction. I want to print out hello world into the browser when somebody invokes this. And, you know, if I come over here and I head over to port 8080 where my Spring application is running, boom, all of a sudden you actually see the inversion of control container code running and supporting my application. This is inversion of control. This is everything that I was telling you about. Now notice, there's no coding to an interface. There's no dependency inversion. There's not even any dependency injection yet, although dependency injection is pretty tightly tied to inversion of control. But you can see that the concept of inversion of control goes beyond, you know, many of the other concepts that are associated with it, right? Just get your business logic to be lean and clean and move all of the complicated stuff to a framework that is better at handling all of that complicated stuff. And, you know, when it comes time to actually call your business logic, the framework will call it. Okay, now, I think this is one of the best examples of inversion of control. I want to show you 4 more that kind of go from the highest implementation of the Hollywood principle to, I don't know, some things that are a little bit lower on the scale, but still fit the bill for inversion of control. Dealing with complicated JDBC database access, that is what I'm going to show you next. So one of the things that I said an inversion of control container should do is it should handle a lot of low-level systems interactions for you. And I demonstrated that by pushing all sorts of low-level networking out of a RESTful application and pushing it to the Spring Boot framework. Another reason you would use an inversion of control container is to help you parameterize and configure objects that require heavy parameterization. Now, in the world of Java, probably Python, JavaScript too, you know, one of those things that always requires a lot of configuration is a database connection. So I've got a database, it's got a table called score, and the score's got wins, losses, and ties in it. And I just want to get the number of wins for the record where the ID is 1. How would you do that with Java code? Well, here's a JDBC query here that, you know, creates a connection object, sets up the query, the SQL, gets a prepared statement, goes to the driver manager, configures all sorts of parameters, and then gets the number of wins from the database and then updates the score object with the number of wins. That's a lot of code there. Don't feel the need to understand that code. Just appreciate the fact that that's a lot of code. Now, if you use an inversion of control framework, the inversion of control framework will take all of that off your hands. You don't have to do all of that configuration. You allow the framework to do it, right? You invert the control. You're no longer responsible. The framework becomes responsible. All of that code there on the left-hand side gets replaced by this if you use Spring Boot. It gets replaced by the declaration of an interface that has the @ repository annotation on it. This is going to deal with the score class. So we tell this interface that, we want to pull information out of a database table and map it to our score class. So we do need a score class, although the score class was used both in the inversion of control Spring container and also in the standard JDBC code. But fundamentally, the code on the right here replaces the code on the left. We do all of the configuration of the database connection. We do the provisioning of the database connection. All of that stuff, we allow the container to do it. And when it comes to our code, all we have to do is just ask that score repository to get us the number of wins, and the inversion of control container takes care of it. In fact, here's the code right here in the score controller. All I have to do is say score repo.findById, the ID is 1, get that record and get me the number of wins, and that replaces all of the code on the left-hand side there. That's how easy it becomes to do database access with an inversion of control container, an inversion of control framework like Spring Data JDBC. And I think I can actually run this. This is actually a RESTful API too, so I'm combining the JDBC with the RESTful API, and /score/wins, I think I can actually get access to that. /score/wins, you got to actually type that in properly. So there you go. And it says there's 30 wins in our database. So okay, I'll take it on faith that there are that many wins. But there you go. Can you see how the inversion of control container takes a lot of this plumbing, takes a lot of this parameterization, it removes it from our code, and allows us to just focus on the business logic. I just want to get the number of wins from the database. So it's one line of code inside this file. There's a little dependency injection there that we'll talk about in just a moment. And then there's that score repository there. It's unbelievable. Now, it did say that there were 30 wins, right? Okay. Now, I'm going to show you another aspect of inversion of control inside of the Spring framework. How do we actually get that 30 loaded in the database? Well, in the Spring framework, you can actually just put a couple of files into your resources folder. And so here's a schema definition there. I don't know if you're big on the SQL, but that says create a score table and put in wins, losses, and ties. There's also a data file that says shove into that database the number 30, 20, and 10. And here's the thing. Whenever I start my Spring container, Spring is actually set up to read those files and populate a database on the fly with, well, it creates that score table and it populates it with this data. Watch. If I type in 35 here, okay, so I'm going to change that number, and then I'm going to restart the Spring inversion out of control container. And now when the container restarts, it's actually going to change the value of the number of wins in the database that it creates to 35. So if I come back to this code over here and I say, hey, give me the number of wins, okay, notice it's now coming up and it's saying 35. So this is inversion of control as well. And it's actually embracing that Hollywood principle. I've just created this file here that defines the schema for the database and defines what we should put into that database. I've never called that code. I've never invoked that code. I've never said run that code, okay? But the Spring Data JDBC framework says, if I ever see those files in that resources folder on my class path, well, what I'm going to do is I'm going to read them and I'm going to populate a database based on them. Okay? I never actually run that code. I never actually do a query or an insert and actually call the database, interact with the database. Instead, the inversion of control container takes the code that I provided and runs it to create that database, to go in and actually create that data. And so again, inversion of control and also an implementation of the Hollywood principle, right? I'm not calling the framework anywhere, asking it to load those files. The framework knows that when it starts up, it should go to the files that I provided. and load them. That is inversion of control. Now, we've got two more examples of inversion of control. One is just showing you how you can do simple inversion of control with the Spring framework, and then showing a little bit about dependency injection too. And if we put all those together, those are 5 separate examples that really drive home the idea of what inversion of control is. And again, I have not spoken about coding to an interface, impl classes, polymorphism, dependency inversion. Again, you don't need to understand those things. You don't need to even speak about those things to understand inversion of control. They're all important topics, but they're peripheral to what inversion of control is all about. So far we've talked about some of the high-level inversion of control concepts and how frameworks like Angular or Spring Boot or Flask or Fast API do inversion of control. But I want to take it down to a little bit more microscopic level here, which might appeal a little bit more to component developers. You can ask the Spring framework to do inversion of control for the classes that you create. It doesn't have to be all about, great big JDBC or RESTful API frameworks. In this code example here, I've got a class called the taxi. I know, it's just a simple class. For the sake of argument, let's say maybe it was something that was heavily parameterized or had complicated lifecycle requirements. And I've said, what? I want the Spring container to manage this. So what I do is I create an instance of the Spring container, and when I create it, I pass an instance of the taxi class to the constructor that initializes it, and that's essentially saying to the Spring framework, I want you to manage the lifecycle of this taxi class, of any instances of this taxi class. By the way, the application context is the technical term for the Spring container. Usually in code, you see that referred to just as the context. I've called it Spring in my code just to kind of be clear that that's talking about the Spring inversion of control container. Annotation config application context is just one of the types of ways to initialize the application context. Java devs are always slagged for components with long names, and that's not doing us any favors there. But the point is, that gets the Spring container to manage the taxi class. And now, whenever I need an instance of a taxi class, I don't say taxi cab equals new taxi. We don't use the new keyword. We don't call the constructor because some other component is going to call that constructor for us. Some other component, the container, is going to take care of the life cycle of the taxi components. And certainly creating an instance is part of the life cycle of any object. So we say to Spring, hey, get me the bean. Spring says, what bean? We say, hey, the taxi class, and we get an instance of this taxi class back, after which we can call any of its methods. System.out.print cab.color. When this code runs, it ends up printing out the color yellow. Now I'm from Missouri. Let's see if that actually works. Run as a Java application, and boom, all of a sudden we get yellow printed out. So there you go. That is us now delegating to the Spring IOC container the lifecycle management of one of our Java beans. That's another example of inversion of control. The next thing that we're going to do is take a look at dependency injection. Now, with dependency injection, we need one class that has a dependency on another class. So let's do this. Let's say every taxi is a meter, right? The meter is, it keeps track of how much the ride costs, right? So we've got a meter here. And so every taxi's got a meter. So let's put a variable in there, meter, something like that. Okay, now every taxi's got a meter, and I guess every taxi's going to have a method called tick. And in this tick method, every time it ticks, the meters.price equals meter.price plus 0.10. I don't know, something like that, right? So every time the taxi's meter ticks, the price goes up by 10 cents. Okay, so what we've got here is I've got a component, this taxi class. I've got another component, and it's the meter here. And the other thing is that this taxi class needs an instance of the meter when it runs. Now, I've actually said I want that meter class, I haven't said it yet, but I want the meter class to be managed by the Spring IOC container. So I've got a taxi class. The taxi class needs an instance of the meter. Where does it get that instance of the meter from? Well, we don't want to create one in our code. Instead, we just want Spring to auto-wire an instance of the meter class into that method anytime we need an instance of it, right? The Spring container is taking care of that annotation. What's the error there? Cannot be resolved to a type. Auto-wired. There we go. Control-Shift. Oh, by the way, do you see that? Did you see that red X there? If you see the red X, you need to get your eyes checked because that is not a red X. That is a white X on a red square. But either way, it's auto-wired, not auto-wire. So I do Control-Shift-O, Control-S to save, and now my code works. But what I'm doing here is I'm saying the taxi class is managed by the IOC container. The meter class is managed by the IOC container. The taxi needs an instance of the meter. Where do we get it from? We have to get it from the container. So we ask the container to auto-wire the meter in. And then I guess we could do something like after we get the cab, we could say cab.tick, which should increase the meter by 1. And then instead of cab.color, we could say cab.meter.price. And let me just format this code a little bit so you can see it all on the screen at the same time. And now when we run this code, run as a Java application, we can see that after a first tick has happened, well, the meter's price is now 10 cents, 0.1, a tenth of a dollar there. So this is now a whole other level of inversion of control. And in fact, what it actually is it's a way to take advantage of the inversion of control container without actually making a reference to it in your code. You have the inversion of control container managing all of your objects for you. You want to actually get one of those objects into your code because you have a dependency on it, rather than actually doing that code that says spring.getBeans somewhere in your code. You can actually just ask for that object to be auto-wired into your code, and Spring shoves it into your code automatically for you. It's kind of like magic. But there you go. That is the fifth level of dependency injection, the fifth level of inversion of control. That is dependency injection, one of the ways that we can get objects out of that inversion of control container. So there you go. That's inversion of control, just this idea that your code will benefit if you keep your business logic clean and push out configuration of highly parameterizable objects, the lifecycle management of objects with complex life cycles, and low-level systems interactions out to a framework that is better designed to handle those things. And then you just keep your business logic pure. You don't have to worry about any of those things in your business logic. And we saw 5 examples of that. We saw a REST API. We saw JDBC. We saw loading of data into a database. We saw inversion of control by directly accessing a bean from a container. And we also saw this magical dependency injection that allows us to actually get things out of that container without having to directly reference it like we did with the taxi class. I think that's all pretty cool, and hopefully this really drives home what inversion of control is all about. And another thing I just want to emphasize, in this whole discussion here, I didn't once talk about coding to an interface. I didn't once talk about polymorphism. I didn't once talk about creating impl classes. All of those things are great. All of those things are important in the world of software development. All of those things are made better by inversion of control and dependency injection. But the dependency injection principle doesn't depend on them. And really, if somebody tries to explain inversion of control to you and they can't do it without talking about those things, well, really, they don't understand what inversion of control is. And I'm really hoping that I've helped you understand the concept with these 5 examples. Now, by the way, if you're, I don't think I introduced myself earlier. My name's Cameron McKenzie. I'm the editor-in-chief over at theserverside.com. serverside.com. And we've got lots of great tutorials over at the serverside.com on Spring, on Angular, on Python, on Flask, on Scrum, on Agile, on Git, on GitHub. So head on over there and check out some of the tutorials that we've got cooking. If you're interested in my personal antics, you can always follow me on Twitter at CameronMCNZ. Did write a few books. There's What is WebSphere back there that doesn't sell too much. There is Pickering is Springfield, all about the true home of the Simpsons. And also Hibernate Made Easy, which some Spring devs are interested in. And also, you notice there's Darcy DeClue's Scrum Master Certification Guide. So I helped do some final edits on that. And people that have been reading it have been taking the Product Owner and Scrum Master exam and scoring 100% on it. So if you're agile working with Scrum, definitely pick that book up. And finally, if you're watching this on YouTube, why don't you subscribe on YouTube?